Thanks everyone for joining. Welcome to the Aptos Network course. Today, we're going to talk about everything Aptos. Today, we're going to walk you through a couple of different sections of content. First, we're going to dive into the background of Aptos, and then we're going to deep dive into the core technology, followed by the DeFi ecosystem and how you can get started on Aptos. All right, let's jump in. A little bit about Aptos. Imagine a truly global financial system that runs 24/7, no matter the time zone, and settles instantly, not in days. Give anyone, anywhere a chance to participate. That handles any asset from stablecoins to tokenized real estate, stocks, or any kind of assets or financial opportunities that you can imagine. Which sadly, today, this does not exist. Trillion-dollar markets still run on infrastructure built for a pre-internet world. It's time for a new foundation, the one that built for an always-on interconnected digital economy, which is the Aptos network. It's the global trading engine where value flows as freely as information. You may ask, why do we need another blockchain yet? We have so many already. I guess the simple answer is all the previous one lacks of the capabilities to support the day-to-day use cases that empower billions of users to use this type of infrastructure. If we can go back into the history, the Gen 1 version of the blockchain really focused on decentralization and security. The representative here is obviously known as Bitcoin. It focused on proof of work consensus, and it's a decentralized store of value. Everybody calls this like digital gold. It's secure and immutable. However, it's limited in the programmability and the scalability, and then very high energy consumption. Also, if you think about it, the latency is extremely high. It's not sufficient to support a day-to-day kind of a payment use case where you wanted to buy a cup of coffee. And then when we move to the next generations of the blockchain, it focused on programmable blockchains and then some early scalability. The most typical case here is Ethereum that enables some smart contracts and dApps to be built on top of it. It has some scalability enhancement. It has higher transaction throughput. However, it's still lack of the scaling really required for day-to-day use cases if you think about it. And then the user experience still remains an issue. Latency remains to be not satisfied still. It's still lack of the throughput and the capabilities to support the scale we need for a truly inclusive financial system. Which is why we moved on to the next generations of the blockchain for real-world utility that focus on high performance with low latencies and guaranteed finality, the low transaction cost that everybody can afford or pretty much can ignore the cost of running on transactions on such infrastructure. It's developer-centric and user-friendly. It's very easy to use, straightforward. Anybody can understand how to onboard and then start utilizing such infrastructure. It has advanced security with minimal friction. This type of infrastructure is designed to support mainstream applications at a global scale. This is where we introduce you Aptos network. The origin of Aptos network is very simple. It was funded by the key members of Meta's Libra DM blockchain project. DM blockchain was focused on building a permission networks that support the global financial infrastructure that provides a stablecoin that really powers the payment infrastructure where billions of users on Facebook and Instagram can transact and do business with each other. And Aptos is built on top of it. So Aptos is built on years of research to create a next-gen blockchain that's highly scalable, secure, and accessible for reimaging global value movement. Aptos mainnet went live on October 2022, and then with 3 years of track records providing very high quality of service, and then hundreds of different dApps built on top of it, providing very low transaction latencies with fractions of gas costs to send transactions on top of this network. Next, let's spend some time to talk about the core technologies that powers Aptos network and then its innovations behind it. Aptos is purposely built to meet the needs of the global economy and deliver real-world value. It's built for very high performance, maximizing throughput while minimizing latency. And it has enhanced capacity horizontally and vertically to meet the global demand. It's built with security in mind to protecting assets with security first design at every layer. It's enabling everyone, anywhere, to participate with low barrier of entries, including costs. It's delivering Web 2-like experience with intuitive designs for both developers and users, lowering the barrier of entries for Web 2 users towards the Web 3 world. It's building an ecosystem where components work seamlessly together across apps and evolving continuously through modular designs with zero disruptions. On-chain upgradability that really powers next generations of innovations to happen on this network seamlessly. That's transparent to user. The most unique piece about Aptos is probably it's powered by the Move smart contract language. It's a next generation language for secure, sandboxed, and formally verified programming. It allows developers to write programs that flexibly manage and transfer assets while providing the security and protections against attacks on those assets that's very valuable to users. It takes cue from Rust by using resources types with Move semantics as an explicit representation of digital assets, such as currency. And its first use case was DM blockchain, which was purposely built to support Meta's social empire with billions of users to transact on top of it. A little bit of a roadmap for the evolutions of the smart contract programming language. On the Move 1.0, we really focused on three big pillars: the resource-oriented programming, safety, security first designs, and Move native standards, which prevents very common vulnerabilities like double spend, re-entry attacks, and then it has like compatible across various different platforms with optimized performance. It also supports formal verifications via Move Prover that allow developers to verify their programs and their specs are correctly implemented with 100% of accuracy that provides different levels of safety confidence. The static dispatch to avoid runtime uncertainty, and security and auditability by default built into the smart contract language itself. Obviously, it also provides function like fungible asset and digital standards that allow developers to program their standards of assets with a lot of flexibilities and composability. In the next generations of Move 2.0, there's a lot of more enhancement and new features come along with it. The smart contract itself has an extensive set of language features like enums, lambdas, traits, and dynamic dispatch, a lot more advanced language features that exist in today's modern programming languages, which lacks on other type of smart contract language in the past type of a generation. It has advanced developer tools like linter, decompiler, formatters, all those very common user-friendly infrastructures and tools to support a better, more developer-friendly environment. It has dynamic dispatch for fungible assets to allow custom transfer functions for each of the assets. And a new Move compiler unifies with Move Prover for faster innovations in the language and verification speed. The Move VM also got a lot of new upgrades. It has stack-based processor designs, optimized memory allocations, and much more modular architectures that are easier to understand and reason about. It has also introduced a lot more advanced DeFi capabilities. Like Aptos Intent declares user intentions for trade and then streamline the DeFi trading. And there's a flexibility evolutions of smart contract data to enhance supports for DeFi applications. So DeFi just get a power enhancement across the Move 2.0 in new features. Aptos is wired for real-world performance, even under very heavy network loads, ensuring all hardware resources work effectively together with minimum idle capacity. Its pipeline architecture separates and optimizes each system components to deliver very high performance end-to-end. A couple of components we can walk through today to really explain a transaction lifecycle. There's 4 different pillars that's really powering through this whole component. Through data dissemination, consensus, executions, and storage. On the data dissemination pillar, we have quorum stores and Aptos to enable fast parallel executions for transaction, propagations with high resiliency under high network load. So there's no interruptions or no degradations for the performance, even during very congested time for the network. On the consensus side, we achieved sub-second latency through Aptos BFT and innovations like Raptors, a breakthrough consensus protocol that maintains security and decentralization while ensuring reliability under heavy traffic. On the execution pillar, we designed for parallel processing via block STM with upcoming technologies like shardings expected to enable horizontal scaling across machines and support up to 1 million TPS. Storage pillar, we have through innovations approaches like sharded JMTs and implementing a tiered storage architecture, the data stored effectively with optimized resource utilizations. Let me introduce you the Aptos approach to scalability. There's effectively 2 big pillars if you think about it. It's vertical scaling and horizontal scaling. So you can think of vertical scaling as like, how can we maximize the capabilities for one single machines to process as much traffic as possible? Horizontal scaling represents even if you're adding multiple machines, it can scale the capacity as the number of the machine goes. It allows the capacity for the blockchains to scale with number of the machines, while verticals is like maximizing. Even if we adding much more powerful machines, it can still provide a better capacity. With different 2 verticals, we have different corresponding technologies to enhance each of the sector. On the vertical scaling factor, we're thinking about Raptors, tiered storage, block STM, and block STM v2, along with quorum store. On the horizontal scaling pillars, we have Aptos, shardings, sharded storage, and execution pools. Aptos combine vertical optimizations with horizontal scalability across the entire system, which will dive into each of those pieces into details as follows. For block STM, this is a revolutionary parallel execution engine that enables dynamic parallelism of transactions. Unlike static parallelism approaches, block STM automatically detects and resolves conflicts during execution, eliminating false conflicts and maximizing throughput without requiring developers to specify transaction dependencies. For the V1 version of the block STM, we can utilize a machine up to 32 cores and then reach 160K TPS in the testing environment that we run this through. And block STM is actually widely adopted through all other different L1s and L2s like Polygon, Say, Initia, Movement. All kinds of different technologies are adopting these technologies to help scaling their infrastructure as well. While everybody's still looking at the block STM v1, Aptos has moved on to the research of block STM v2, which enhanced the signature execution engine, scaling from the 32 core to 256 cores for dramatically improved hardware efficiency. A single node now can process massive transaction volumes, laying the groundwork for horizontal scale at a global level. This can 8 times plus on the capacity one single node can process on Aptos network. So the next generation of the research is already being deployed and worked on at the Aptos network, while other blockchains still trying to catch up on the first generation of the block STM technology. Next, let's talk a little bit more about the end game of consensus, Raptor, the ultra-fast execution consensus protocol that being researched and developed inside Aptos. It's a new BFT consensus protocol that achieves the BFT elusive trifecta. First, it provides extremely high throughput, and it has nearly optimal latency with decentralized robustness. If you think about the consensus landscape, there's 2 different paths of thinking about consensus. One is DAG-based consensus, where the pro is parallelism and then very high throughput. However, it comes with the trade-off of higher latencies and some reliability trade-offs, with a little bit of packet loss or disruptions of the node reliability. It can drastically degrade the performance of this consensus protocol. And there's another approach, which is leader-based consensus. The upside is very low latencies with a lot more simplicity. However, the risk of bottlenecks and then performance degradations under very heavy workload. So it doesn't really scale when the traffic on the network is very high with a lot of users. But combine this two with both of the upside, we get Raptor, which can reach 250K TPS with sub-second finality without really compromises. And Raptor is providing resilience under true decentralized networks. It can survive network disruptions and validator delays while still provide very high performance with guarantees. A little bit of history of a path to Raptor. The research has been working on in the past for BFT-based consensus, focused on latency improvements and throughput improvements. Obviously, on the throughput axis, we want the more traffic, the higher performance, the better. And then we want lower latency, the faster finality, the better. For Aptos, we have been making a lot more incremental improvement from the very beginning of the times, from Narwhal and Task, which is a paper that released in 2021, and then evolving into Bullshark, Shoal, and Shoal Plus, which all those paths focused on DAG-based consensus protocols. Leader-based consensus optimizations, we have Aptos BFTs, which is the production version that deployed with Aptos Mainnet in 2023, that evolved and improved into Aptos BFT v4. And then both of the paths really eventually converge into Raptor, which is the end game of consensus that combine all the upside of both paths and reaching a better outcome. This is a paradigm shift in the consensus design. Raptor's key innovation is the prefix consensus with combined the robustness and fault tolerance of pessimistic approach with the speed and responsiveness of optimistic protocols. By optimizing data dissemination, prefix enable faster block commits without compromising safety. With Raptor, we can, in theory, reach over 250,000 TPS on a mainnet with sub-second latency and around 750 millisecond of a latency. This is in a mainnet-like environment and continues to perform reliably, even under very high network-wide glitches. Let's dive a little bit into Raptor's technical design with the 3 pillars of main innovations. First is prefix voting and partial commits. Instead of requiring full block data, replicants vote on the longest prefix of batches, of which they have the data locally. So this approach will increase the efficiency and ensure that consensus can move forward even under partial data availability. And then a second pillar is on decoupled consensus availability and safety quorums. Consensus availability is achieved with just F+1 quorum certificate votes, while the remaining quorum certificate votes in the quorum can be shorter prefixed. This allows Raptor to maintain speed even when some of the replicas lack the full data. And then last but not least is the parallel data dissemination. Decoupling transaction disseminations from consensus, replicas now can broadcast their transactions in parallel. This significantly reduces the delays from leader bottlenecks and then enhances the network performance in the geo-distributed settings, really enable the decentralized networks to shine and maintain the kind of performance even in a very distributed validator location. Next, let's dive into the sharded storage, the Aptos solution for distributed storage. Storage is the slowest resource on a computer. Beyond a few tens of thousands of TPS, it is hard to scale storage, and there aren't any fast enough disks available. But storage maintains to be one of the problems every blockchain has to solve, because on the blockchain, data is stored forever. You really can't bypass this bottlenecks and this challenge for any protocol. Sharded storage spreads the I/O loads among multiple disks and then scales the commit phase of the protocol within the number of disks. The key benefits of this is in the three main pillars. One is scalable storage. It increases storage capacity and access speed by distributing data across multiple nodes. And it reduces bottlenecks. Avoids single point of failure by distributing the load, enabling high throughput data access. It has improved decentralization, enhances the decentralized nature of the network by ensuring that no single node holds the data on the single machine. And another pillar of storage scalability is on the tier storage for the disk efficiency. Tier storage optimizes the way data is stored by dynamically allocating frequently accessed data in high-speed memory, which is what we call a hot storage. Less access to data to disk, which is what we call the cold tier, which is also cold storage. The key benefit of introducing this type of a change is for memory efficiency. It reduces pressure on memory by keeping less used data separate on disk, and also improve the accessibility, ensure quick access to critical data by storing it in memory. It lowers the cost. It optimizes the storage cost by using disk for infrequent access data, maintaining very high performance of data access. Next, let's talk about execution pool. This is a distributed resource allocation designed at Aptos. Execution pool acts as a buffer in between consensus and execution. It will intelligently extract maximum parallelism from transactions and ensuring that sequential workload don't clog block space. The result would be dynamic resource allocation that provides smooth, predictable network performance, even under very heavy load. Key benefits of the execution pool design is for parallelism. For parallelism, it maximizes the throughput by isolating sequential transactions and allowing parallel ones to execute simultaneously. For improved efficiency, it prevents resource contention by decoupling execution from consensus and dynamically allocating computes. For stability, it ensures smooth and predictable performance even under peak traffic by minimizing the bottlenecks in the execution layer. Next, let's talk about Aptos, which is a pipeline optimization that's very unique designed at Aptos. Aptos optimized the entire transaction pipeline as a unified system by allowing consecutive stage of blocks to execute concurrently. This end-to-end optimization unlocks the deeper parallelism and pushes the latency to absolute minimum, which will enable new possibilities for value transfer across markets. This is the secret weapon that Aptos has to really sustain sub-second latencies even under very heavy transactions, like over 20,000 TPS happening on the network, and still maintain very good performance and then very low latency for the user experience. This has 40% latency reductions during high active period of time. Imagine any networks, even providing sub-second latency when the network is idle is difficult. While Aptos, we can provide sub-second latency even during the high congested times of this network processing very heavy load. Let's dive into Aptos, the technical design. First is the optimistic execution. Validators start executing blocks immediately after receiving them, even before they are fully ordered in consensus. Allow validators and full nodes to execute the blocks while it's being verified. Second, optimistic commits. Blocks are committed to storage as soon as execution is complete, before the state is certified. If the blocks is not finalized by consensus, the state is reverted for data consistency. Third, a piggybacking state certification. Validators begins certifying the state of executed blocks earlier. This runs in parallel with consensus to reduce latency by one round. Next, let's talk about sharding. It's Aptos sharded execution. Sharding is an execution engine that eliminates the CPU bottleneck by scaling execution across multiple machines, achieving infinite horizontal scalability. This represents a fundamental paradigm shift in the blockchain technology, demonstrating that execution can scale infinitely without additional resources, something previously thought impossible in decentralized systems. Sharding can theoretically enable linear scaling to 1 million TPS and then maintaining around 40,000 TPS per shard. The technical designs of sharding is as follows. First is decoupled execution and storage. Sharding enables independent scaling of execution and storage, ensures high throughput without performance degradation. It has a dynamic partitioning, uses hypergraph modeling to minimize cross-sharded communication, enhances data partitioning efficiency. And it does a micro batching and pipelining, processes transactions in smaller overlapping batches, reduce network latency, and increase throughput. Finally, it's the execution coordinator. It coordinates execution across shards, optimized performance, and resource efficiency. We walked through a lot of core innovations of Aptos, but there's many more that we couldn't cover in depth. There's a lot more additional user features listed as below. First is Aptos aggregators. The benefits is it will dynamically increase NFT minting speed drastically and then performance by 10x. This allows tracking of global counters without sacrificing parallelism. You can imagine this enables applications that uses a global trackers or need global resources without having to think about compromised performance, and then it enables much more TPS on-chain in real world. Aptos also has a very secured on-chain randomness, that instant delivery of unpredictable, unbiased random values. There's no external dependencies or commit reveal delays. Lots of very fun and creative applications can be built with this feature, like on-chain casinos, pokers, and all kinds of randomness-based games, if you can imagine that. Sponsored transactions, which simplifies onboarding and engagement by covering the gas fees for user. This enables low-cost trading for users bridging in from the many other different chains. And we also have keyless account that effortlessly onboarding with one click of Google login and any type of a social login, like Apple's, Discord. You can imagine for the futures of different type of login choices that developers can choose from. This provides seamless embedded access across devices. There's no external wallets required anymore. Aptos account abstraction allows permissioned delegation of apps and then enable multi-sig accounts. This enables developers to create applications with their own customized logic for account management, gives much more flexibilities of managing the account without going through a lot more user difficulties or thinking about the complexity of Web3 technologies. Let's go through some data for the performance benchmarks that we did on Aptos mainnet. There's over 326 million transactions in a single day, 19.2 thousand peak TPS on mainnet, under 600 millisecond user finality, 125 millisecond block times, 100x lower gas fees than other L1s with a fraction of a cent, with 100% uptime streaks since October 2023, providing a reliable, high-quality service on Aptos mainnet for all kinds of users and applications to run powered on top of it. Aptos global distributed validator networks ensure high reliability, censorship resistance, and 100% uptime, while maintaining sub-second finality across geography boundaries. There's over 500 total nodes on Aptos network today that's streaming transactions and then forwarding transactions for all the users' applications, and then over 150 validator nodes across 22 countries and then 47 cities. It's a truly decentralized L1 networks, have its footprint across the globe.